Good morning, I'm Ruth Godwin, and the following presentation will detail the reaction that occurs between copper and nitric acid. All around us on a daily basis, chemical reactions are taking place. These reactions can be thought of as a rearrangement of the molecular structure of a substance, which eventually leads to the chemical transformation of one set of substances to another. The ensuing presentation demonstrates the chemical reaction between nitric acid and copper and explains the mechanisms of the reaction. The reaction between copper, a transition metal, and nitric acid, a mineral acid, leads to an impressive visual reaction that is easily visible. The process of this reaction is fairly simple, as nitric acid is merely being added to a copper penny. This addition leads to a redox reaction occurring and results in the formation of an aqueous solution and a gas. One note to mention is that pennies minted prior to 1982 must be used. Pennies minted after 1982 are comprised of mainly zinc and not copper. Therefore, they will not react with nitric acid. However, before 1982, pennies that were minted are comprised of 95% copper, and that's why they must be used. The following video will show the reaction occurring. As can be seen in the demonstration, a copper penny is placed in the bottom of the test tube and nitric acid is being poured over it. The chemical reaction begins very quickly and results in a blue aqueous solution forming in the bottom of the tube. The solution is copper nitrate and water. Additionally, a reddish-brown gas flows from the test tube. This gas is nitrogen dioxide. You can also see that the copper nitrate solution is bubbling. This indicates that an exothermic reaction is taking place. The test tube, if felt, will be hot to the touch. The copper and nitric acid will continue to react until the reaction is complete, in which case the nitric acid would stop bubbling. The reactants in this chemical reaction are copper and nitric acid. As was noted on the introductory slide, for every mole of copper that is used, 4 moles of nitric acid are required to complete the reaction. Nitric acid is a colorless aqueous solution. As we learned, it is a strong acid, which implies that it can dissociate completely. In addition, nitric acid, being a strong acid, it is highly corrosive and even in its dilute form will react with copper. Copper, on the other hand, is an unreactive metal. It typically does not react with acids under normal circumstances. However, nitric acid is one of the exceptions. As mentioned previously, copper will react even in the presence of dilute nitric acid. The reaction between copper and nitric acid is an exothermic redox reaction. Redox stands for oxidation-reduction reaction. When two reactants are mixed, it causes copper to oxidize and lose electrons, while nitric acid is reduced and gains electrons. An exothermic reaction is a reaction in which the solution is losing energy. In this case, the energy loss is exhibited in the formation of heat. This production of heat results in the solution bubbling. It also results in the test tube being extremely warm to the touch. Since copper is an unreactive metal, you may ask why this reaction occurs. Even though it is usually unreactive, it will always react with nitric acid, even in its diluted form. The reason copper will not react with other acids is due to the fact that when they are mixed, copper is not able to displace the hydrogen bonded to the anion. In this reaction, however, nitric acid acts as an oxidizing agent, allowing for copper to replace the hydrogen. Typically, the hydrogen of the acid will be the oxidizing agent. However, in this instance, the nitrogen acts as an oxidizing agent. In the reaction, the oxidation number for nitrogen is reduced while copper's oxidation number increases. This means that copper is oxidized and nitrogen is reduced, making nitric acid the oxidizing agent. The products that result from the reaction between copper and nitric acid are copper nitrate, nitrogen dioxide, and water. For each mole of copper nitrate that is produced, 2 moles of nitrogen dioxide and 2 moles of water are produced. Copper nitrate appears in the form of a blue solution at the bottom of the test tube. The solution would be hot since the reaction is exothermic. If the solution was allowed to cool down and the water evaporate, you would have anhydrous copper crystals formed in the bottom of the test tube. These crystals will be bright blue in color. Nitrogen dioxide is the brown reddish gas that is emitted. It is a foul-smelling and poisonous gas, and if inhaled, is an irritant to humans. Interesting to note, nitrogen dioxide is also a component of smog, and that is seen hovering over large cities with plenty of pollution. It is what gives pollution its brownish tint. In summary, for this reaction to occur, 4 moles of nitric acid are required for every 1 mole of copper that is utilized. This will result in 1 mole of copper nitrate, 2 moles of nitrogen dioxide, and 2 moles of water. Copper is typically an unreactive metal that does not react with acids. However, it does react with nitric acid, even in its diluted form. This occurs since nitric acid acts as an oxidizing agent, allowing copper to replace the hydrogen. Although hydrogen usually acts as an oxidizing agent, in this reaction it is the nitrogen that allows for the replacement of the hydrogen. When copper reacts with nitric acid, an exothermic redox reaction occurs. Copper is oxidized, nitric acid is reduced, and heat is released into the environment. When the reaction between these two substances is complete, a copper nitrate solution is produced and nitrogen dioxide gas is released as a byproduct. The following resources were utilized in preparing this presentation.